Afternoon session. Just to go over a couple of things. Once again, we are recording. I ask that you keep yourself muted. If you have questions at the end of our various sessions, you can pose them two different ways, one in the chat and one by raising your hand, and you can see the little face and the hand up in the upper right hand corner so we can call upon you. And with that, I would like to introduce our next speaker, who actually is not with us. She did a pre-recorded message to all of you. Heather Hecklethorn is a hydrologist for U.S. Geological Survey and serves as a water quality specialist for the USGS New Jersey Water Science Center. So Jess, go ahead and you can play her presentation.
Great, and let me know if it's not coming through once I start it. Did that just stop? Oh, there we go.
I'm not sure if I have a mic on here, but there's no video playing.
Jess, it's not playing. There, okay.
Or there's no audio.
So, well,
if it's
so you can't hear her talking? You can't hear her talking?
No.
Usually. What about now? Can you hear her?
No.
No, we can't hear her.
How about now?
No, maybe if you might bother your neighbors, you unplug your headset and just have it play through your computer.
Now can you hear?
No.
No. Jess, why don't we skip over and go to the next speaker, and if you're able to get the get it to work, we can go back to Heather. How does that sound?
Sure. Hold on one second. It worked this morning, usually how it happens, right?
Yes.
Let me. We'll skip her. So next we have Scott.
Yes.
So 1 second, let me.
So Scott, I'll introduce you. He is the Senior Fisheries Biologist in Division of Fish and Wildlife here at DEP. For the last 8 years, he's worked on the capacity of manager for fisheries in the Passaic and Raritan River drainages. His passion is the conservation of native fish species, with a current focus on identifying resilient cold water habitat, the impacts of stormwater on wild trout streams, and the protection of uncommon native fishes. With that, Scott, turn it over to you.
Thank you, Carrie. So I'm going to be talking about temperature impacts on indicator species in New Jersey, specifically in upland headwater streams in the northern tier of the state that support cold water fish species, and drawing a connection between impacts on these species that we've documented and how that connects to HABs in New Jersey. So next slide. So it's important for us to identify and protect resilient cold water habitat in the face of climate change. And this habitat is relied upon by our only native trout species, brook trout, which is pictured there to the left, and other wild trout species that have become naturalized in New Jersey, such as brown trout and rainbow trout, and also our only other native cold water fish species in the state, slimy sculpin, which is pictured there to the right. So all important indicator species that act as a signal for high quality water in our state. But I'll be focusing a lot on brook trout in this talk because of how well they've been studied and their historical importance to classification of New Jersey waters. But a lot of these impacts that relate to brook trout relate to many of the species that share similar habitat. Next slide. So brook trout have had a difficult history, sensitive to environmental disturbances. They've been subjected to declines throughout their range due to human impacts like poor land management and forms of urbanization. But this map is from a report published by a partnership group called Eastern Brook Trout Joint Venture. And the map is displaying Eastern brook trout's historical range and their current status. And you can see they're gone in the gray areas on the map. And greatly reduced in the red areas in many watersheds where they previously existed. So large shrinkage of their range there. So I just want to draw your attention to the second leading threat to brook trout is high water temperature. And this is primarily through the removal of streamside trees, vegetation, and warming from dams. But this is obviously only going to get worse as air temperatures increase due to climate change. So next slide. If you click one more time, Jess. So in regards to climate change, some projections indicated that cold water habitat in New Jersey would essentially be gone by the year 2100, regardless of warming scenario. However, these projections didn't account for an important metric that varies on a very fine spatial scale and is very important to cold water habitat, which is groundwater. So next slide. So we started a plan to continuously monitor summertime stream temperatures primarily in places we've documented brook trout. So between 2018 and 2021, we monitored 242 locations with the idea to understand resilient cold water habitat or identify resilient cold water habitat, understand groundwater influence, and then prioritize protections in these places, and then identify projects at places that we were calling strongholds for brook trout and cold water habitat, and identify locations that we could potentially fix with help and make more resilient to climate change. Next slide. So we used the stream temperature data that we collected as well as air temperature data to create predictions and estimate groundwater influence, which is projected on the map to the left. And we made projections on how air temperature would influence stream temperature based on climate change scenarios, which was done on a site-by-site basis where we had stream temperature data. So the major finding or takeaway that I want you to get from this was that by incorporating direct measures of stream temperature data in models, our outlook on the future of cold water habitat and brook trout was much more optimistic. So if you're looking at the statement on the left there, for instance, our models showed that a warming scenario of 3 degrees Celsius increase in air temperature we'd lose approximately 35% of cold water habitat, right? But yeah, which isn't good news, just more optimistic than previous models that didn't account for spatial variation in groundwater influence. So next slide. So as part of this stream temperature monitoring, an issue we identified based on our data has been that wild trout streams were impacted a great deal by stormwater. So this is where our data, I think, really ties in well with HABs, as these headwater streams are acting as conduits for pollutants, toxicants, nutrients that may be leading to an increased likelihood of a HAB downstream. So between 2018 and 2020, we found that approximately 20% of our sites that we were monitoring classified as trout production C1 waters, which are waters afforded the most protections in our state, documented stormwater impacts. So the heat map on the right is showing frequency of stormwater events in relation to our stream temperature monitoring sites, which are those blue dots on the map. Next slide. So this is just to give you an idea of what one of these stream summertime temperature graphs look like when there are stormwater events. So you can recognize some of those large spikes in temperature, and they're in relation to rainstorm events that are happening. So I highlighted with a red box the most kind of egregious of these at this site, which took place on July 22nd in 2019, an increased temperature in the stream, 6.5 degrees Celsius, and lasted 16 hours, reaching almost 23 degrees Celsius. If you click once, Jess. And those blue arrows are showing the other stormwater surge events that occur at this site as well. Next slide. So what I'm going to share on this slide, I think, helps visualize what's going on as opposed to just looking at a graph. I'm going to show a video that I shot with a thermal infrared camera that was attached to my phone. And this was shot in the springtime, last spring, a few minutes after a rainstorm began, and I was lucky to be in the area of this known impacted site. So this is a brook trout stream called Sun Valley Brook in the Raritan River drainage up near Bud Lake, which this stream no longer contains brook trout downstream of this impact, but it does, interestingly, above this impact. So the video is on the right side of the screen here. And it kind of splits the image into half thermal infrared on the right, and the completed image on the left is standard view. So if you can go ahead and play that, Jess, I think the little play button's in the left corner. Yeah. So the stormwater drain is at the top of your top of the image or the video. And you can see it dumping into the stream, and kind of just focus on the temperature impact. That's, the temperature difference, I guess, that the thermal infrared camera is picking up on between the stormwater that's entering the stream and the actual stream water where it's mixing. But it's not just temperature impacts here, although temperature impacts are important because this is a cold water stream. It's also the mixture of pollutants that are coming into the stream with the stormwater that are impacting the trout downstream. So you can jump to the next slide, Jess. This is just, I have just one more video here. This is actually upstream of that impact, but it's the same exact stream. This one's showing what's typically an empty channel during prior to a storm event, is actually being a corridor for storm water from a housing development directly into the stream. So if you can go ahead and play that. So again, we're just looking directly upstream or up this channel that's typically empty. It's carrying the storm water directly into this trout production stream that used to hold brook trout. And it's a lot of water, a lot of storm water, probably 100% storm water. And if you could skip ahead to about 45 seconds, Jess, on this. I just want to show the contrast between the actual stream channel that's not impacted and then actual stormwater that's entering the stream. I just thought it was interesting. So this is me just walking up the stream that's relatively unimpacted by stormwater. And you can just see how different the stream is when it's not impacted. So you could jump to the next slide. So these two pieces of analysis aren't too surprising, but we were able to show statistical significance between the magnitude of stormwater events and the amount of altered land upstream of the site of these impacts. So altered land being defined as the percent of urban land and agricultural land covered together. And then we were also able to show statistical significance between increased numbers of stormwater events at each site and the absence of wild trout. So the increased number of stormwater events are causing trout not to be there anymore. So I thought that was quite interesting. I just wanted to share that. As you jump to next slide. So these events are also contributing to nutrient loading into water bodies downstream. And these are just a few examples of how impacts on important indicator species and HABs are related, and addressing stormwater may not only help make cold water habitat more resilient, but reduce the potential for HABs to occur downstream. So I don't know if you could see very well the green circle. It's a very tiny dot on the map, but it's in the middle of that giant red circle. but that's where the temperature monitoring site sits on Preakness Brook in Bergen County. This is a location that historically had brook trout, no longer does. And the large red circle is just indicating the frequency of stormwater events there at this monitoring site that flows into Barber's Pond. You skip to the next slide. And this is just another example. This is just a tributary to Ravine Lake in Somerset County, showing stormwater impacts into the water body downstream. Next slide. And this is the Bud Lake area. And I show this because I know HABs have been happening annually at Bud Lake. And we didn't have any sites on tributaries that fed directly into Bud Lake, but downstream of this lake is a location that we believe is one of the strongholds for brook trout in our state. There's lots of preserved land, resilient cold water, and groups of interconnected tributaries teeming with brook trout. And I show all these maps and cases to make the point that we're not only addressing HABs when we're mitigating these impacts, but helping make cold water habitat more resilient to climate change in the future. So next slide. And that's all I got.
Thank you. Thank you very much, Scott. I think that we have figured out the gremlins, and we're able to now play Heather's presentation to us. Jess?
Yep, 1 second. Sorry, couldn't hack it under pressure, but here we go. Now let me know if you can't hear her. Hold on, I haven't started yet. I have to go back to see you all. Okay, ready?
Good afternoon. I am presenting a study on the downstream production, persistence, and potential transport of cyanobacteria and associated cyanotoxins in the Raritan Basin Water Supply Complex in New Jersey. This is a comprehensive multi-agency collaborative study over the course of 3 years to evaluate the spatial and temporal variability of cyanobacteria and cyanotoxin occurrence, production, persistence, and downstream transport. The advanced monitoring strategy that I will be presenting today helps provide insight on rapidly changing water quality conditions that affect cyanobacteria and associated toxin production and transport. As you heard this morning, harmful cyanobacterial blooms in New Jersey are increasing in occurrence, duration, and magnitude like so many places worldwide. In both 2020 and 2021, 4 of the water bodies impacted by cyanobacteria were at drinking water reservoirs, as well as several additional lakes that were upstream of water supply intakes in New Jersey. Some of the blooms have been documented each year, and some persist throughout the year, even during the winter. Some water bodies are lucky, or in this case, unlucky enough to have both recurrent and persistent blooms. Detections of microcystins, a cyanobacterial toxin, are ubiquitous throughout New Jersey. Recently, saxitoxins, one of the most potent known neurotoxins, were detected in recreational and potable freshwater sources in New Jersey, and the presence of neurotoxin anatoxin A was detected in 2 of New Jersey's drinking water reservoirs. These are only the places that have been looking for these toxins. There may be cyanotoxins present in water bodies that aren't being monitored or assessed. And then in addition, during a 2019 investigation on the Spruce Run Reservoir, genes that are capable of producing cyanotoxins, specifically anatoxin A, saxitoxins, and microcystins, were detected in samples from the reservoir, which is a source water supply in the Raritan Basin Water Supply Complex. So based on this knowledge, the Raritan Basin Water Supply Complex is of particular concern, as it provides the source of water supply to utilities serving more than 1.5 million people in central New Jersey. The New Jersey Water Supply Authority manages the infrastructure and operates the Raritan Basin Complex and provides raw water to water purveyors who then treat the water. There are 3 water bodies in the Raritan Basin upstream of the water purveyor intakes that have had confirmed recurrent HABs over the past 3 years. These water bodies are Spruce Run, Bud Lake, and Rosedale Lake. Well, although HAB occurrence and persistence were documented in all of the upstream headwater lacustrine systems within the Raritan system, there were no data prior to this study regarding the potential cyanotoxin production, persistence, and transport to the downstream drinking water intakes that are used by water purveyors serving millions of New Jersey residents. There are many groups in New Jersey interested in HABs for a variety of reasons. A group of interested agencies and academia, including federal, state, and academia throughout New Jersey, partner together to focus on the Raritan Basin Water Supply Complex with these 3 main study objectives. The first is to assess cyanotoxin production and transport downstream to drinking water intakes, to evaluate conditions that influence cyanotoxin production and transport, and then lastly, to evaluate the ability of passive samplers for cyanotoxins to capture ephemeral toxin transport that can be missed by traditional sampling methods. And I'll go into this a little bit more later on. So these objectives may seem like we're shooting for the moon, but I can't emphasize enough how this project is possible with such a collaborative group. We selected a total of 9 sites throughout the study area using existing USGS stream gauging stations whenever possible. 7 continuous water quality monitors provided near real-time water quality data, and 7 sites with continuous real-time stream flow data. Due to budgeting constraints, 2 of the 9 study sites were limited to discrete only or GRAB sample data. So in summary, there are 5 fluvial sites, 3 outlets of lake and reservoirs, and 1 is on open water. The lacustrine sites, as previously mentioned, all have had recurrent HABs during the past 3 years. One of the source water bodies, Rosedale Lake in Mercer County, had the highest cyanobacterial cell count and toxin concentrations in 2019. The 5 downstream sites are sampled to capture conditions that are upstream of drinking water intakes. So zooming in on the map to highlight the locations of the lacustrine sites, which are circled in red. Again, all of these water bodies have recurrent HABs. Bud Lake, the northernmost site, Spruce Run Reservoir, and then Rosedale Lake, the southernmost site in the study. So now that we know where data are being collected, your next question might be what types of data are being collected, when, and why? Current HAB monitoring relies primarily on analysis of discrete samples, which provide a snapshot of the phytoplankton community and cyanotoxin content at a specific location and point in time. However, lacustrine ecosystem is rarely homogeneous, as we know, and the downstream transport of HABs from these systems is likely to be affected by many environmental factors. With that said, the project relied on a combination of continuous, discrete, and passive sample collection over a 13-month period during 2020 and 2021. To conserve time, I won't go into great detail at this point, but welcome questions at the end of the session. So this leads me to, in my opinion, one of the most interesting parts of the study. While information gained from discrete data and continuous data are useful, innovative tools can provide further insight into rapidly changing conditions over time. And so we used solid phase adsorption toxin tracking technology, or SPAT technology. This has the potential to capture ephemeral cyanotoxin events that can be missed by traditional discrete sampling. For example, the neurotoxin anatoxin A, which had never been detected in measurable concentrations in discrete samples in New Jersey, was detected in spats by USGS in 2019 within the Raritan system. The data gained within the Raritan system will be valuable as we evaluate the efficacy of these spats and spat technology and gain additional information on toxin presence in water supply. Several laboratories are involved in this project, which requires a great deal of coordination and logistics among our partners. 3 of the 8 labs that are included in this study are overseen by primary investigators of the study. Those are NJDEP's Cyanobacteria Laboratory, NJDEP Bureau of Marine Water Monitoring Laboratory, and Montclair State University's laboratory. This project is leaning heavily on Montclair State University faculty and students for the analytical component, field component, and project oversight by Dr. Mayan Wu and her team. And Montclair State University is one of the few laboratories in the state of New Jersey certified by DEP to perform analysis of microcystins. NJDEP laboratories are performing analysis of a suite of nutrients, as well as the analysis of 3 cyanotoxins. And again, we greatly appreciate the expertise and partnership with DEP, specifically Bob Schuster and Dr. Rob Newby, both of DEP as primary investigators of the study. Numerous USGS labs are involved in this study, including USGS in New York Water Science Center Cyanotoxin Lab, led by Dr. Jennifer Graham, as well as USGS Ohio Water Microbiology Laboratory, which is led by Amy Brady and Dr. Aaron Stelzer. And again, for the purpose of this presentation, this is a long list of labs, and it shows the massive collaboration of the project. We had hoped to have more data to share, but we are in the data analysis phase of the study, so we can only provide a glimpse. By looking at the data from discrete samples from the 3 headwater lacustrine systems, the cell density of Bud Lake, the upstream reach, was 20 times greater than that of Spruce Run Reservoir, which was 3 times greater than that of Rosedale Lake, which was monitored at Stony Brook. Data from a total cyanobacterial cell density sample from August of 2020 was pretty remarkable, with the greatest cell density at Bud Lake at almost 500,000 cyanobacteria cells per ml and 96% relative dominance for cyanobacteria. Total microcystins were detected at concentrations greater than 0.15 milligrams per liter at 6 out of the 9 sampling sites. And again, these data are preliminary, not yet published or examined from a study perspective. These hydrographs show some preliminary continuous monitoring data for phycocyanin at 1 of the upstream reservoir sites, Spruce Run at Clinton, and 1 downstream site, Raritan River at Manville on the right. I won't get too far into interpretation today, but I wanted to point out the different scales on the y-axis for both sites, with the upstream site reaching phycocyanin levels of 10 micrograms per liter versus the downstream site having maximums of approximately less than 4 micrograms per liter on the right. Is this due to dilution as constituents flow downstream? Are the environmental conditions at the reservoir site prime for cyanobacterial production and HABs formation? As scientists predict that climate change may have many effects on freshwater and marine environments, having these long-term data sets of continuous data will also help scientists assess the conditions that might cause HABs to form or occur more often in more water bodies and to be more intense. And again, we can't draw any conclusions right now, and this study alone won't give us all the answers, but we hope that results from this project will help us give us a better understanding of the research questions related to the production, persistence, and downstream transport of cyanobacteria and associated cyanotoxins. With that said, there are several publications anticipated in trying to answer a number of research questions and to characterize the dynamics within the Raritan Basin water supply complex. All data will be publicly available via the USGS NWIS web, and or through scientific data releases expected later this year. We definitely have our work cut out for us. And this is a great segue to illustrate how we can make all of this sample collection, data analysis, and writing happen. And it's thanks to our entire project team. Enough can't be said about the collaboration among agencies, primary investigators, and our project teammates. The role and responsibilities of each agency and each team member is unique, but the benefits are collective, and not just within the state of New Jersey, but nationwide. And I just want to take a moment here to pause and express gratitude to this amazing team. In wrapping up, please don't hesitate to reach out to me or any of the study partners if there are any questions. I was a little limited in time today and couldn't get into a lot of detail, but we are excited to share this project and study findings with you in time. The slide deck will also be available after the summit concludes. Thank you again.
And our thanks to Heather for pre-recording that message for us today. We're now shifting to Dr. Nick Procopio, who is the Assistant Director in the Department's Division of Science and Research, where he manages the collaboration of the multidisciplinary research of the division. He's co-led the development of the department's recent science report focused on the impacts and effects of climate change in New Jersey. And today he's actually going to be talking about future precipitation intensity projections. Go ahead, Nick.
Thanks, Carrie. Thanks for the invitation to be here this afternoon. It's great to share this new research with you. Jess, go ahead and give me the next slide, please. All right, so I hope everybody is aware that in June of 2020, the department released its first scientific report on climate change. In that report, we discussed the likelihood that we will see changes to extreme precipitation. And when I say extreme precipitation, I'm thinking of the events, or we're talking about the events like the 100-year storm, which is most familiarly termed, or maybe some of you think of it as the 1% storm, the storm that has like a 1% chance of occurring each year. And so we recognized from the literature that's out there that New Jersey and at least the region are likely to see the values, the precipitation depths, if you will, associated with these extreme events increase into the future. We didn't have specific New Jersey centered data, so we identified that as one of our research gaps and needs. And so, following the release of this report, we sought input from colleagues outside of the department, specifically Dr. Art Degatano, who is with Cornell and is also the director of the Northeast Regional Climate Center. And we asked him to do two things for us. One, we asked him to evaluate what would happen if we added data to the current NOAA Atlas report, and I'll come back to that in a second, basically to give us a current picture of what extreme precipitation looks like in New Jersey. And then, and maybe more specific to this discussion today, is to project extreme precipitation events out to the end of the century. And so that's mainly what I'll focus on, through this talk. And next slide, please. And give me one more little tap, Jess, please. Okay, so I don't expect you to be able to read necessarily the what is on that table with those little red arrows. But what I want to point out is many practitioners out there, many of you may be listening, have referred to NOAA Atlas 14 as a resource to identify what the storm depth would be associated with, say, a 100-year storm or a 2-year storm, the amount of rain that might fall within 24 hours. And so what this table does for us is allow us to pick the return interval and the duration of a storm, and based on previous data, determine what, how much precipitation would be associated with the storm. What I'll point out with this, it was last updated in 2006, and it only includes data through 2000. It's now 2022. So that first question that we asked Dr. Degatano to report to us was how would these values change per se if we added another 20 years of data, the 20 years of data that are, since available to this report. And so what he was able to document for us in that first study, next slide, please, Jess, is that indeed, if we look into not just into the future, I'm sorry, I'm getting ahead of myself. If we just look at filling that hole, right, in the absent data, the storms that are of a 12-hour, a 24-hour, or 48-hour duration increase by at least 5%, right? And so those longer duration storms are increasing, or I should say have increased, maybe it's a better way of saying they have increased relative to the data that is currently published in that, that general reference. The shorter duration, the 1 hour, 3 hour, 6 hour storms don't seem to have changed all that much by adding that additional 2 decades worth of data. But certainly the 12 hour and longer storms, so figure these rainstorms that sit on top of us for longer periods of time, we do get inundated, and they're changing from 5 upwards of 10% increases. So we take that information to help tell us that yes, indeed, the climate is changing and has changed just even by adding 2 decades into an already 50-year period of data. We can see and document that changes have occurred. So next slide, please. So then what we do next is ask Dr. Degatano, say, okay, we validate that question, that part of the question. Yes, climate has changed. Now, can we project into the future? And so we asked Dr. Degatano to take the best available climate science models that are available and basically focus in on New Jersey and do the best that we can to project out to mid-century and then out to the end of the century. And so he was able to compile 47 different models, so again, used to estimate change in magnitude of future extreme rainfall events. And I emphasize magnitude because these studies both look at magnitude. They don't speak to frequency, how more frequent these storms would be. It's an assessment of how the storms themselves will change in terms of magnitude, in terms of how much rain will fall. And so if you're interested in the modeling component, just some terms here so you see how these were built. There were 2 modeling approaches. One is called a Cordex model and the other is called LOCA models. The difference has to do with the scale in which they're constructed. We'll see a little bit of that in more detail as I move along through the slides. And then ultimately, when we compile these models together, we have development of change factors which can be applied to the NOAA Atlas 14 values, those that I showed you in that earlier slide, those that are currently published. So change factors, just think about them as percent changes. So we can apply these percent changes to the currently published data to get an assessment or an estimate of what future precipitation is going to look like. Next slide, please. Okay. And so those changes are provided for 2 different time periods, as I've mentioned, right? Mid-century, which would be 2020 to 2069 time period, about 2050 in the middle there, and then late century, 2050 to 2099, so end of century. And it's important, I guess, to point out these are not specific individual year projections, and they really can't be, because you need about a 50-year time period to be able to get enough data, enough years worth of precipitation change to figure out and model what the 100-year storm will be, that 1% storm. So you need an adequate sample size. And so when you model these, you have to model them back to about that same envelope of time, about 50 years, which is good in a way too, because it helps us minimize influence of non-stationarity, or the idea that there are variations from year to year. So trying to nail down what a particular extreme event might look like in a single year is very difficult because of the fluctuations. So 2 different time periods and 2 different emission scenarios, two different ideas of what future climate might look like. And they're based on RCP 4.5 and RCP 8.5. And these RCPs are basically a way that modelers project how much climate warming gases are going to be added to the atmosphere. And so if you will, RCP 4.5, that's usually described as a moderate emission scenario, a moderate warming future, and it relates to about a 3.2 degree Fahrenheit warming by the end of the century. The high emission scenario is an RCP 8.5, and that translates to about a 6.7 or so degree warming, 6.7 degree Fahrenheit warming by the end of the century. So I would encourage us to think more likely that an RCP 4.5, that moderate emission scenario, or somewhere below that is really where we're moving into the future. The RCP 8.5, that high emission scenario, is good for modeling the extremes, but might not be exactly where we're heading, especially if we are able to meet all of the commitments that we're engaged in. Next slide, please. And so, if you're interested in these, how the analysis is worked, we develop these change factors, CFs again, right? And it's based on comparing the different time periods back to the 1950 to 1999 base period. And so the projections are relative to that 1950-1999, that 50-year time period. And so an increase, basically, a change factor of, say, 1.05 represents a 5% increase in future precipitation. 1.1, for example, change factor, if you were digging through the report, would be equivalent to a 10% increase in precipitation. And so next slide, please. And so ultimately, the climate models are modeled down to grids across the state, grids that are about 6 miles square. And so each one of the models, and we'll look at those really quickly next, then get aggregated to a regional scale, much like you're seeing here. Next slide, please. And using these next two slides just to sort of build on this idea that the climate modeling is very dynamic and includes many, many different inputs. And so what we're seeing here, this is an example of one of the depictions of the LOCA model. Remember, I said there were two different scales used. This is a much more localized, higher resolution model. Each one of the dots that you see in the map basically represents a model grid that was used. And what we see in the bar chart on the right is basically the 30 plus different models and the variability associated with every one of those models. The red dash in the middle of each one of those bars is the average for that model. But you can see by those tails that go kind of high up into the upper end and maybe some of the dip down low. Even though we're using 30 plus different models, they all come within their own assumptions and expectations and variability assigned with them. And so next slide, please. And so I'll come back to this point. And just to compare that LOCA model with the Cordex model, this is a coarser grain model. We see fewer of these little dots, if you will, right? The grids in which they're modeled. And we also see fewer models associated with this. So here we're looking about 9 different models that are associated with this Cordex mix. And then ultimately what we do, and next slide, please, is we aggregate the two sets of models, the LOCA and the Cordex, into those 6 mile by 6 mile or so grids, those that we saw a couple slides back. And this is an aggregation. It's basically pulling the 40 plus models across LOCA and across Cordex to grab that variability in the different scales and the different extremes and be able to plot out at some unified focal geographic area what the likely precipitation change, extreme precipitation, is going to be in small finite areas. And so what we're seeing here is taking those 47 or so different models, combining them together, aggregating them at a unified grid scale, and then we can see the median of those models. And I should maybe add too, each one of those models are run 1,000 times. So really, we're looking at 47,000 iterations to develop this median likelihood in the future. And then, so what we're looking at is the median, or if you will, loosely, the average expected change. And this is for a 100-year storm at the end of the century under a moderate emission scenario. That's on the left-hand side, and then on the right-hand side is the 83rd percentile, or what's usually referred to as the upper end of a likelihood, at least in the climate modeling. So this gives us that margin of error that we might be interested in on what is sort of the higher end of what we would expect, still under a moderate emission scenario, right? There's a lot of variability. So what's that variability on the more protective side? And that's what the 83rd percentile will do for us. And notice what we're seeing up in the upper parts of New Jersey, the north and the eastern parts. We're seeing more and more, let's say, higher and higher likelihoods of increased precipitation and change factors upwards of, in some of those areas, 50% on the 83rd percentile side there. Next slide, please. And so some of the key findings to try and wrap this up is that, one, there's a high likelihood that precipitation intensity will increase into the mid and late century. Hopefully I was able to project that. And under a moderate emission scenario, projections suggest that the amount of precipitation associated with the 100-year 24-hour storm will increase, this is important, on average by as much as 22% in the northern counties, right? And so if we were to break this data down by counties, which I'll show you next, that median percentile, median likelihood, under a median likelihood of all of these models, we see some counties increasing as much as 22%, and some counties more in the southern part of the state are increasing their precip by about 10%. The 100-year storm, the 100-year 24-hour storm, under that higher likelihood, we would say that there's a 17% chance that precipitation will increase by as much as 45 to 50% in some counties, less than 25% in some other counties like Ocean or Hudson County. And then I think one other point to emphasize here too is that this study is looking at intensity, not frequency, and we're also looking at those extreme events, right? So nothing that I've talked about today has to do with average annual precipitation. This is just simply looking at those extreme events. And so maybe important to emphasize here too, the connection to the conversation at large, the HAB conversation, is that the simple fact that as precipitation associated with these events increases, so will the runoff, so will the transport of nutrients to our streams and lakes. And as the increased pulse of nutrients enters those water bodies, there certainly comes the increased potential and likelihood for HABs or HCBs, HAB blooms, right? So that's the connection. That's the important part or important reason why I'm here talking about precipitation. That increased precipitation is going to ultimately increase runoff of those nutrients that we're so concerned with. Next slide. And so just wrapping up with a couple of pictures here, right? This is taking that data that was once aggregated by grids or all those little points we were seeing in the back, and then just aggregating them, averaging them by county, doing a weighted average by county. And this again is the 100-year 24-hour storm and that upper likelihood of what we might see. And so we can see the counties up in the north and east as being those that are going to most likely see more intense increases in extreme precipitation. And so there's, countywide estimates mapped geographically for you this way, but the reports, so next slide, please. The reports themselves are filled with tables much like this, where you could take county by county, which was the way we asked Dr. Degatano to present the data. County by county, you can see for different types of storms, 100-year storm is what I'm showing you here, but it could be a different, there are examples of different return interval storms and different time periods. So here we're just looking at the example clipped right out of the report. This is the 100-year return interval for the late century storm or at late century for a moderate emission scenario, right? And so we can see those change factors. And again, the change factor, if it's say greater than 1, what you're seeing is, for example, Atlantic County, the median is a 10%, 1.10 change factor is a 10% increase. And then also showing the projected stream precipitation depth that would be associated with that change, right? And that's relative to that current publication at NOAA Atlas 14. And we are expecting to produce some type of an interactive web tool where you'll be able to pick your county or a town, and it'll be able to pull from the data from this report and present that data for you. We expect that to be available the next couple of months or so. So keep your eye open for that. And then my last slide is just thank you again for the opportunity to share this information with you, but also take a quick peek, maybe jot down, if you will, those 2 links under the title there. They will get you basically to the same place, to the reports that I'm discussing here. So take your time, go through those. My information is also on the slide for contact if you want to discuss any of the results and what they mean, how they can be applied. I'm always happy to do so. So that's all I have. Carrie, Katie, Jess, thank you all for the opportunity.
Thanks, Nick. Pretty sobering. Okay.
Yes, keep your eyes out for the storms. Yes.
Our last speaker in this segment is Dr. Nicole Lewis. Dr. Lewis is currently the wildlife veterinarian for the New Jersey Fish and Wildlife Division of Fish and Wildlife. Dr. Lewis graduated with a master's degree in 2012 and her veterinary degree in 2013 from Atlantic Veterinary College in Prince Edward Island, Canada. And today she is going to be talking about keeping your pets safe from HABs. Dr. Lewis?
Hi, everybody. Thank you for the invitation to speak. This is going to be a little bit different compared to the past or previous talks today in this session. It's not really a research study. It's just giving you some information on what you can see impacts with your pets as well as some others. Next slide, please. So I'm just going to talk a little bit and briefly in my 10 minutes I have about animals that are commonly affected, what you can see, their signs and symptoms, how it's treated, if it's able to be treated, and what the prognosis is, and then what steps you can take to prevent poisoning in the first place. And because I'm the state wildlife veterinarian, I'm also going to spend just 2 slides on impacts to wildlife. Next slide. So what animals are affected or can be affected by a hazardous algal bloom? Dogs and cats, so your domestic pets, various livestock species, horses, and then the wildlife side, mammalian wildlife and avian wildlife, as well as us, which has been discussed. So the toxin will enter the body of an animal that drinks the contaminated water, which tends to put animals like hunting dogs and dogs who love the water, like my dog in the top right, at an increased risk of exposure. Livestock and horses not only can become affected by drinking from these lakes and reservoirs that are affected, but also from stagnant water in their drinking troughs. So you can get a bloom in their drinking troughs as well. Cats are also susceptible, but their behaviors make them a lower risk. So cats don't like to swim usually. There are the rare cat that does, but you don't usually see that in your reservoirs. And they tend to be a little pickier about what they drink overall. Next slide. So what happens when they are exposed? It really depends on the toxin that's involved and the organ that it targets. So you have hepatotoxins, such as microcystin. Hepato means liver, so these are cause liver failure, and that's typically within a few hours of exposure. So you'll see vomiting, diarrhea. The diarrhea can be really dark and tarry, and that tells us as veterinarians that there is some digested blood happening. That's where the tarry comes in. There's bleeding, there's pale gums. You can see jaundice, which is what you see with liver failure. That's that yellow skin and gums that happens not just in pets, but also in humans. They tend to go into shock as the exposure goes on, and then will ultimately die from this. Another one is a neurotoxin, so that's anatoxins. You can start seeing signs of poisoning with this within 30 to 60 minutes of exposure in animals. Most of this is particularly for dogs, but other species can be affected as well. You'll start to see muscle tremors and rigidity, paralysis. You'll see cyanosis, which is a lack of oxygen to the tissues, which usually you can tell that they have cyanosis because it means blue. Their skin becomes a bit blue. And they can also have hypersalivation. You can also see paralysis of their diaphragm because the diaphragm is also a muscle, and that leads to respiratory failure and death. Death's usually quick with that one, often within minutes to hours after exposure. Livestock that drink from contaminated ponds that have neurotoxins are often found dead right at the water's edge. The third one, which is not seen, I would say, as often or talked about as often, is dermatoxin. So derma is skin. You'll see itching, redness, and blistering of the skin within hours of exposure, but it's not typically fatal, but it can take a really long time to resolve and to go away. Next slide. So then how is it treated if they're exposed? It's prompt treatment is key. As quick as you can get that animal to your veterinarian, the better. If you know your pet has consumed a potentially toxic algae, you need to go to the vet, yes, within minutes, right away, as soon as you possibly can. Because if you catch if you catch it before there are clinical symptoms, such as in dogs, veterinarians will treat it by trying to get rid of that ingested toxin before it gets absorbed into the body. So once it's absorbed into the body, you start seeing the clinical signs. So if there are no clinical signs and it has been prior to that development of clinical signs, veterinarians will induce vomiting and then follow that up with activated charcoal and fluids to try to remove that from the stomach before it can be absorbed and lead to death. But because they're so fast acting, most of the time, the animals are usually sick by the time they reach their veterinarian, and vomiting won't do anything because the toxin's already in the bloodstream. So the only options then are supportive care. And that's usually focused on the organ that's affected. So we talked about the hepatotoxins, so the liver is impacted, neurotoxins, the brain is impacted. So supportive care usually means fluids and any medication that's going to help mitigate some of the clinical symptoms, like having seizures. We'll use anti-seizure drugs, liver protectants, that sort of thing. So there's no magic pill or anything we can give them to make it go away. It's just supportive at that point. Next slide. So unfortunately, prognosis is really poor. Particularly with blue-green algae toxicity in dogs. Some animals, a lot of animals will die on their way to the veterinarian. That's why it is so important to get their animals to the vet as quickly as possible. So even if you suspect it, if you don't recognize that it's, or don't know 100% that it's a hazardous algal bloom, but you saw algae, it would behoove you to take your pet immediately to the veterinarian. You can also call the pet poison helpline, but I would recommend doing that on the way to the vet instead of calling them first, because time is precious. Next slide. So the best best medicine is prevention in these cases. So how can you prevent it so that these things don't happen? Because the prognosis is so poor, prevention is definitely key. So you want to block off any access to these algal blooms. Don't allow your dogs to swim in them if you know there's an active bloom or you see something that just doesn't look right. It's recommended to fence off contaminated ponds and lakes to prevent livestock from using those and to provide them with clean, regularly cleaned troughs for drinking. With dogs who swim, they also not just drinking the water from swimming, but they'll lick their hair coat after, and that can also be fatal. So pet owners should keep that in mind. Not all types of algae are deadly. It's the toxins they're producing that we're worried about, but without knowing for sure, the safest consideration is to avoid it altogether. Next slide. So I'm just going to talk really briefly about wildlife because that's what I do. And HABs, wildlife can certainly be sensitive to certain types of toxins produced by HABs. There's a few examples with saxitoxin causing paralytic shellfish poisoning in birds. Birds seem to be pretty sensitive to a lot of these. I have not had any cases in my current role as of yet. I don't know if it's just not sure who to call, which we'll talk about on the next slide, but we also can see brevetoxicosis and domoic acid toxicosis, which is associated with red tide events. Domoic acid is pretty commonly seen in some wild birds out west in California. They are often brought to places like the San Diego Zoo and are treated and then re-released. Some actually do quite well with supportive care and treatment against domoic acid, and then some do not. There has been a case in Utah. I know someone from Utah spoke this morning. I'm not sure if they mentioned this, but there was a case in little brown bats that were found dead during a HAB event at a reservoir that's used for both recreation and as municipal drinking water. Sometimes there's algal toxins detected in wildlife, but we don't really know whether it contributed to their mortality or not. There's so little known about the lethal doses and their impacts on wildlife. So often the toxic dose is just unknown in wildlife species, or they don't exhibit symptoms or have lesions on necropsy that are well described that we can look at and say, yep, that was likely related to an algal toxin. That data is just not out there, but there is work being done to try to determine those things. So there's ongoing research to determine lethal dose of toxins in birds. That's just one example. Next slide, please. So what should you do if you find sick or dead wildlife near a HAB or near a known HAB area or a suspected HAB area? We really want you to report it. If the animals are sick and they're found near a suspected or known bloom, you have a couple of options. You can reach out to the local animal control and they will come and bring the animal either to a veterinarian for assessment or to a rehabilitation facility. Or you can contact one of our permitted wildlife rehabilitation facilities in the state. The link there is a list of all of them by county. So it gives their address and phone numbers. So you can find the one closest to the event and they can guide on the best practices. I wouldn't recommend handling dead wildlife without proper protection or without the guidance of either myself or one of the wildlife rehabilitators. If the animal is deceased, I want you to reach out to me. That is my job. I will do a necropsy on the animal, collect tissues, and we can do some testing. There is some testing available to look at toxins in various organ systems. It's pretty limited, and like I said, there's not a lot known about the lethal dose, but the more information we can get and based on clinical signs and presence of an algal bloom and findings on necropsy, we can have a better idea of what the impacts might be, and it may help add to that body of knowledge that's currently out there on what to look for in an animal that is found dead near a HAB. So that's all I have. Next slide. I want to say thank you again for having me. I think that was pretty quick, but I'm happy to take any questions. I don't know when the questions are happening, but I'll be here for them.
Thank you. Thank you, Nicole.
Thank you.
So we have been talking about a number of things today. Everything from the national kind of picture to funding to Governor Murphy's agenda on HABs and the science of HABs. And now we're going to shift to some preventive measures and mitigation. So our next speaker is Taylor Copa. She is the Assistant Project Manager for the Stormwater Infrastructure Toolkit Project. She currently works in DEP's Division of Resilience Engineering and Construction, focusing on flood risk reduction. And she is going to be presenting on the Stormwater Toolkit. Taylor?
Thank you, Carrie. So good afternoon, everybody. Today, as Carrie mentioned, I'm going to talk about our Stormwater Toolkit, which was recently made available to the public last fall for free. I'll put the link in the chat. It includes best practices for stormwater management, which can reduce flooding and help control your non-point source pollution. Next slide. So today I'll discuss the benefits of stormwater operations and maintenance. And then I'm actually going to share my screen and show you the Stormwater Toolkit website and discuss how we implemented our toolkit in the Meadowlands as part of the Rebuild by Design Meadowlands project. Next slide. So as we know, stormwater systems are getting frequent use every time it rains. So as rainfall events increase, maintenance of our stormwater assets will become even more critical. So assets can consist of, but not limited to, your inlets, pipes, culverts, pump stations, and retention basins. So we all know that some of the infrastructure in this country is aging, and the reality is we don't even know where all of it is. So it's important to remember not only the large pieces of equipment that we see above the ground, but also all of the equipment that is located underground. And it's important to take note of all of this since these assets are essential to protecting public health and reduce flooding. These assets can be managed on a municipal, county, or regional level. We all know that water doesn't follow the municipal boundaries, so a great example of regional coordination would be towns coming together to form a stormwater utility to reduce flooding. To assist with managing stormwater and maintaining assets, we've created the Stormwater Toolkit. So with that, I'm going to share my screen and share that with you. All right, so as I said, this is a free resource that can be referenced at any time. You can even Google NJDEP Stormwater Infrastructure Toolkit, and it'll pop up in one of the first few URL links. You can also access this toolkit through DEP's climate change website. This toolkit is geared towards city managers, DPW workers, stormwater coordinators, engineers and planners, but of course it's available for everybody. So the toolkit homepage will appear first, and from there you can access all of the resources either by scrolling down on the page here and clicking on one of the options, or by the tabs at the top, which is what I'm going to walk through today. So the asset management drop-down menu includes resources for creating an asset management plan, And the first page provides some initial core questions to get you started, such as what's the required sustained level of service? What's the current status of all of your stormwater assets? We also have additional resources, including how to start an inventory of all of your stormwater assets, your pipes, culverts, etc., and then noting which ones of those are critical, and that you would probably want to prioritize those. So there are different software systems out there to help you track all of this, and you can check out the asset management tools drop-down menu to learn more about those. And if you don't check everything out within the Toolkit website, I highly recommend checking out our asset management software assessment tool. It's under the asset management tool page here. And what it does is it prompts you to answer about 10 questions, and then it recommends software systems for tracking all of your assets based on the needs that you've identified. We're gonna go through it real quick. So here it recommends kind of your basic software system based on some of the initial questions that we just answered really quick. And then here's some software systems that might be applicable, some additional listed here. All right. And a really cool example of technology that we'll be using in the Meadowlands as part of the Rebuild by Design project is supervisory control and data acquisition. So we call it SCADA for short. And what that means is that once we construct our pumping station, we'll be able to view the status of the pumps, the generator, if power is out, from a web browser with internet connection. So that way, if you know that there's an issue and you're getting a lot of rain, the area is starting to flood, you have an idea of what's malfunctioning or not working before you even get to the pump station. The Management Entity tab provides resources for how to manage this effort. Like I said earlier, this could be done through a municipality, county, or regional approach. So for the flood risk reduction project in the Meadowlands, we used a watershed-based approach by looking at 5 towns and then identified kind of where those flooding bottleneck areas were. And we're designing stormwater infrastructure to address those challenge areas. The jobs training drop-down menu includes different training classes and resources for stormwater operations and maintenance. So some of these trainings are online or in person. Some provide a certification or are specific to green infrastructure. So you can either browse through these web pages or you can check out our jobs training opportunities tool, which, like the other tool I just showed you, it'll prompt you to answer a few questions, and then it will direct you to the web page most applicable to what you're looking for. So the last resource that I want to mention today is a maintenance card template. It's located under the Jobs Training tab. So we plan to implement this in the Meadowlands also. It is a template that can be downloaded, filled in, and then used while you're out in the field. You can fill it in for each asset that needs maintenance. For example, if you have a rain garden, you could put in the address of where it's located, a photo or a plan view, and then a description and frequency of the tasks needed to be complete and how often, and any monitoring or inspection requirements. So again, this is a really cool resource, just came out last fall. So I'll put the link to it in the chat. And please feel free to reach out if you have any questions about it. And I just want to say thank you very much for letting us present this today.
Thank you, Taylor. It is a great tool. We appreciate your sharing it with us. So our next speaker is Mike Pissarro. He is the Policy Director for the Watershed Institute. He is a practicing attorney for over 25 years. And at the Institute, he engages with state and local officials to improve and protect New Jersey's watershed. Today, he's going to be talking about stormwater management and green infrastructure. Mike?
Great, Carrie. Thank you very much. And I want to thank DEP for this invitation to this great conference. I've learned a lot so far today, and hopefully we'll continue. All right. Jessica, I'm not sure, I don't see the slides.
How about now, Mike?
I do. All right.
Okay, here, let me move. Okay, there you go.
I'm seeing myself twice. That's not good. All right, next slide. Just very quickly, the Watershed Institute is located in central New Jersey, but we do work regionally and statewide. There's our mission, and we do it through conservation, advocacy, science, and education. Next slide. Those are our strategies. Since I'm the policy director, I'm mostly interested in advocacy with some science. Next slide, please. All right, so stormwater management, and I sort of cribbed this from the Stormwater Management Act of 1982 or 83, I always forget. So the goals of stormwater management is to reduce flood damage, to ensure adequacy of existing and proposed culverts and bridges. So we want to make sure we're not flooding those systems out, reduce soil erosion, maintain the integrity of stream channels, maintain groundwater recharge, and prevent an increase in on-point pollution. Next slide. And so just, we all know this, we've all been seeing it, we've heard about the increases in rainfall and flooding, but here is some just local pictures from around my watershed of flooding. And these are not necessarily the Idas of the world, but just decent heavy rains. Next slide, please. So, stormwater management has been around since 1983. The modern current stormwater management that we all know and love has been mostly around since 2004 with some major paradigm switches in 2020. Next slide. But, as I said, the goal of stormwater management is to prevent and reduce flooding. And as you heard earlier, we're experiencing more rain. So I borrowed this from one of the Cornell studies. Again, from Mercer County, I borrowed it from. Our 2-year storm is 3.3 according to the NOAA Atlas 14, but in reality, it's really 4.3. And that 100-year storm is 8.3, according to the Atlas and current the way we design our systems. It's really 9.3 inches. So as we are designing our stormwater management systems, because of the data we are using is not current, we're under designing those systems. And we're not really accommodating what we're currently experiencing, not alone what we are expecting to have to deal with over the next 50, 80 years. All right, next slide. And those events are also changing. It's no longer, maybe it was never really sort of those 24-hour storms, but we're getting heavy precipitation events. Those really extreme events are increasing, according to Climate Central, about 55% here in the Northeast, but also the pattern. So we're getting those 2 inches, the 2-year storm happening in a couple hours, not 24 hours. So our systems are really designed for a world that we may not be experiencing and will continue to change. All right, next slide, please. And again, we saw this chart in probably a little better detail. What we're expecting is going to increase. So we should start thinking about, as we are designing our stormwater systems, or we are designing our regulatory regime and our local ordinances, how do we accommodate not only current, but the future? Next slide. So not only is it a sort of flooding issue and a volume issue, but Kim Seno had these charts up earlier. It's a water pollution issue. So stormwater management is rooted under the Clean Water Act. And the goal of the Clean Water Act is to restore and enhance our water quality. And this chart was borrowed from the 2018-2020 integrated report, where we're showing a significant amount of non-support. Next slide, please. And then I just, for comparison, pulled from the 2010 report, very similar chart, different colors, slightly different categories, but still. So taking a look at this, water quality, of which, you know, temperature and nutrients and others is a component, we're seeing over the last 10 years or so, water quality at best staying stable, if not decreasing slightly. I wanted to go back a little farther, but the way DEP did the integrated reports, I believe, changed a bit. So it wasn't necessarily apples to apples. And being a lawyer, math and statistics were not my strong suit. So this became really easy. Next slide. So as I said, you know, right now, stormwater management is designed to sort of put the brakes on decreases in water quality, decreases in flooding, protect our stream banks. But what is really happening, it seems that at best it's keep holding the line or slowing the rate at which we're degrading. Current stormwater management only kicks in when you are disturbing an acre of soil or creating a new quarter acre of impervious surface. So only large developments are addressed. You're not addressing existing stormwater problems. So any development that occurred in the 40s, the 50s, the 60s, 70s, and probably even part of the 80s occurred most likely without any stormwater management whatsoever. So you know, the volume, the rates, the TSS reduction never happened. So you have a huge chunk of the state which developed before stormwater management and have no control. So how do you sort of deal with that? As we talked about, use of out-of-date rainfall amounts and when we design our systems, nutrients, you know, so going to the HAB situation, you know, the stormwater rules say you shall address nutrient pollution to the maximum extent practicable. You know, unlike TSS, which has an 80% reduction unless you're in C1 waters, there's not a numerical target. Is you must address it. And I have attended, it's probably not an exaggeration to say, hundreds of planning board and zoning board meetings have reviewed at least as many, if not more, stormwater management reports. I'm not sure I've ever seen the word nutrient ever addressed. Now, the green infrastructure rule, which DEP adopted and put in effect in 2020, hopefully will get at this indirectly. But nutrients is not really a focus of our stormwater management. And then we're really looking at peak rate reductions. So the quantity reductions in the stormwater rules, where you're supposed to reduce the existing rates, is again a rate reduction out of volume. So as you're increasing impervious surfaces on our properties and our developments, you're increasing the volume. You're not decreasing volumes. You're not necessarily controlling volumes. You're trying to address the peak rate. And so our systems are having more volume to deal with. And I forgot to put in here a picture of an eroded stream bank, in part because of the intense volumes that are being used. You know, we went back to this site a couple times over a few years, and you could really see the difference in that stream bank. And I wish I had remembered to put that in there. All right, next slide, please. So, you know, we have some problems. We have the green infrastructure rule, which DEP adopted in 2020. Municipalities were supposed to implement by March of 2021. So the use of green infrastructure using plants and soil to infiltrate and use the stormwater. And again, applies to new major development. It doesn't apply to existing development and doesn't apply to things under that 1 acre or quarter acre of impervious surface. And it requires treatment of quantity, quality, and recharge. Encourages the use of smaller systems that treat stormwater closest to its source. So the green infrastructure rule breaks down the use of green infrastructure, but into drainage areas of 2.5 acres or less. So we're trying to decentralize stormwater management, bring it closer to the source. So you will have more systems that are smaller and greener to address the problem. And also added a mitigation requirement. So if you can't meet the standards on site, you can get a waiver or a variance and do a mitigation project somewhere else within the same drainage area and with the same standards. And also protecting all these systems with deed restrictions so that the systems are constructed, they're installed, and then they're protected by deed restrictions so a future property owner can't come in and remove them or ignore them. Next slide. So, you know, we've heard rainfall is increasing. The interesting presentation on the increases of temperature in trout streams and those impacts are occurring. Increase in rainfall, the increasing of HABs. We're seeing more and more HABs. So what are, you know, we have these state basic rules, but what can we do to address them? And what can we do to sort of get out ahead and maybe start to chip away at the problems we are seeing? So some of the thoughts the Watershed Institute has on this and others, environmental organizations, can we take some and reduce the major development? Can we reduce that 1 acre trigger, that quarter acre of impervious surface? Can we create a minor development requirement? So some stormwater management happens. So as you add to your property, add to your house, that may not have had any stormwater management beforehand because it was built before the 80s. Can we add it as you are doing some improvements? Started to chip away sort of those sins of the past. Address redevelopment. Again, if you develop before stormwater management and you go to redevelopment, the stormwater rules are not a really good tool currently to address redevelopment and retrofit them. But municipalities can enact ordinances and are enacting ordinances to bring the full suite of stormwater management to sites as they redevelop. Again, leverage natural features like native ground cover and existing trees. DEP's new MS4 permit, which is in pre-draft, is going to have a tree protection ordinance requirement as part of it. You know, trees are a stormwater management system, a BMP, so to speak. So trying to maintain those and protect those are important. Required treatment from all impervious surfaces. Right now, the current rules require them only for motor vehicle surfaces, but our roof runoff collects pollutants, collects and increases temperature. Our roofs are hot. And so as that water getting discharged, can we treat that better? Set a numeric standard for nutrient removal. If you are having a nutrient problem, if you are in areas maybe with high agricultural, is there a way we can keep those nutrients on the agricultural land so it doesn't run off, benefit to the farmers, benefit to our streams? And how do we sort of collect all of the stormwater treated for nutrients so it doesn't cause those HABs? And then add a volume requirement, really truly do a quantity. So some towns are adding a on-site retention standard, 1.25 inches, 1.5 inches, keep that on site, reuse it. There are multiple ways to do that if you can't infiltrate, but keep it out of the system so you're not having those impacts downstream. All right, next slide, please. And so this is where I'm going to borrow from my science department. We've undertaken several projects, some of these smaller scale voluntary things that have been used sort of as a basis for some of the ordinances we've worked with in the municipalities. The upper left is a floating wetlands project in Rosedale Lake. You heard about that earlier from USGS. And then a project where we installed a bunch of green infrastructure in Hopewell Borough. Both of these were part of a 319H grant from DEP. So DEP, again, thank you very much for funding these projects. Next slide. The HAB project of floating wetlands was in Rosedale Lake, which is man-made lake, I believe, where Stony Brook enters in and then continues on. We constructed about 1,000 square feet of constructed floating wetlands in partnership with Mercer County. Next slide. And going back a little time afterwards, those floating wetlands really took off, provided habitat, as you can see, and hopefully is starting to remove some of those nutrients. But as I mentioned, if we address the nutrients beforehand, we won't have to remove them once they get into the stream system. So better stormwater management through local ordinances is a really good step. Next slide. And here's the Hopewell Borough project, again, 319. This is part of a multiple year project where we installed stormwater green infrastructure sort of retrofitting, 9 properties overall. About 3 million gallons of stormwater runoff is supposed to be mitigated through this. And we're doing this in 2 phases. Phase 1, we did 4 properties. Next slide. And so taking an existing site where there was very little of any stormwater management, putting in a rain garden. So this is Hopewell Borough Municipal Building, following the contours of the land and the runoff, and putting in green infrastructure. Next slide. Again, here was an existing stormwater basin that was kind of sort of functioning, retrofitting in it to be green infrastructure. So you see some before and after. And it's important to note this system was in for a couple of years. There was a huge rainstorm about 8 months after it was installed, and it survived. And it survived Ida. Next slide, please. Again, taking a swale that existed, really beefing it up to be a bioretention system, and keeping some of that TSS, some of those nutrients out of the system that would drain right into the Beaton Brook. Next slide. And here are some things, it doesn't have to be a floating wetland. It doesn't have to be a major system. Some of these are, but in the upper left, a downspout planter, taking water that's coming in from your downspouts. You might have them directly connected to your storm source, disconnecting them, putting them through some green infrastructure, some soil, keeping some of that volume out, cleaning it up, what is discharged. There's a green roof, which I believe is on Princeton University. There's the rain garden here at our watershed center, where we have 4 rain gardens, a cistern, porous pavements. We have a lot of practices that are used. And this is just the one on the bottom right is actually a really neat system. It's sort of a green roof. They collect it from the downspouts into barrels, the rainwater, where they can then hand pump it back up. They have literally a little lawn sprinkler on the roof that twirls and sort of irrigates that roof when it needs. It's a really fun little thing, but that's there in Mercer Meadows here in Hopewell Township. There's also voluntary projects through the River Friendly program, which also I should have added a slide. So steps homeowners can take to better care for their land and hence our waterways. All right, next slide. And I think that is it. I greatly appreciate this opportunity. And if anyone has any questions, there is my contact information. I will put the contact information for Steve Torto, who's our Director of Science, who did the green infrastructure projects, the floating wetlands, and the Beaton's Brook project. So again, thank you, and I look forward to any possible questions.
Mike, thank you so much. So moving right along, we have 2 speakers, Kelly Mascarenas, who is an environmental specialist in the Bureau of Environmental Analysis, Restoration and Standards, and Lauren Drum, who is an environmental specialist in the Division of Land Resources, Resource Protection at both of the DEP. And today they're going to be talking about the benefit of riparian buffers. Kelly and Lauren.
Thanks for having us. Thank you, Carrie. Our presentation is titled The Benefits of Riparian Zones in Preventing HABs. My name is Kelly Mascarenas. I work on the surface water quality standards, and my co-presenter is Lauren Drum, who works within the Bureau of Freshwater, Wetlands, and Highlands Permitting and the Land Resource Protection Division. Next slide. Next, for our presentation, we'll focus on first defining riparian zones and their importance, their role in preventing HABs, and then specific riparian zone widths that are afforded to New Jersey waters. And Lauren will go through regulated activities in riparian zones that require a permit under the Flood Hazard Area Control Act, which is known as the FHACA rule, and then describe other nuances with riparian zones occurring in different conditions. Next slide. So to begin, riparian buffers are defined as the land and vegetation within and adjacent to a regulated water and include the regulated water itself. This definition is in the Flood Hazard Area Control Act rules. Riparian zones, when they're measured, are assigned specific widths that are measured starting from the stream bank going landward. You'll often hear the phrase riparian buffer as well as riparian zone, but in the Flood Hazard Area Control Act rule, riparian zone is the preferred scientific term, but both phrases mean the same thing. And traditionally, a 3-zone model has been determined to be the most effective for protecting the integrity of a stream's water quality, as shown in this diagram. So in the diagram, zone 1 is closest to the stream, and it's preferred that it contains undisturbed existing or planted forest. And the next zone should consist of trees and shrubs, where you can periodically remove trees and shrubs as needed for management purposes. The function of these first 2 zones closest to the water are mostly for filtration of the water through the sediment and nutrient uptake. And the third outermost buffer zone is usually a grassy plant community that can be grazed or similarly managed. The main function of this last zone is controlling the flow of water into uniformity and encouraging soil percolation and nutrient uptake. Next slide, please. So to give you the idea of a riparian zone's importance and its ecosystem services, I thought it would be helpful to detail exactly what goes on when riparian zones aren't there and when vegetation is disturbed adjacent to streams and diminishes over time to give way to development. A great paper was written by Marjorie Kaplan at DEP and Mark Ayers at USGS in 2000. They were examining the negative impacts of impervious surface increasing to watersheds. I've circled which impacts may lead to instances of harmful algal blooms. So to begin, well, impervious surfaces are defined as any material that prevents the infiltration of water into the soil, such as sidewalks, roads and buildings, and other concrete and asphalt impermeable surface, really. As that increases, surface runoff increases in volume and velocity during rain events because water filtration through the soil is decreasing. When you have surface runoff and stormwater runoff, it may increase up to 2 to 16 times its pre-development rates. With less water infiltration through the soil, that leads to reductions in groundwater recharge. And then when you have increases in surface runoff, that can give way to erosion. Specifically, natural streams may have their banks widening because of increases in peak flow and volume. And with this erosion, any riparian vegetation on the banks of these streams may be washed away because of this or due to other disturbances from construction. As you lose vegetation on stream banks, it may result in changes to the water temperature of the regime of your stream, From this, waters would be exposed to more solar radiation and may become warmer by up to 2 to 10 degrees Fahrenheit in the summer. And these last two bullets, or two boxes, impact aquatic species and streams that are sensitive to temperature and loss of habitat, such as trout. Next slide, please. Also, air and ground temperatures in these paved impervious surface areas may be 10 to 12 degrees higher Fahrenheit than the vegetative forests and fields that they're replacing. To go back to runoff, from surface runoff and road runoff, you get the dispersal of road salts and pathogens, mostly fecal coliforms, into water bodies that will increase. And other items such as seeds can be dispersed from road runoff and potentially lead to the introduction of invasive species, as well as revegetative inhibition of native plants in the area. And then road salts themselves can lead to an increase in water body salinity. When you are having an increase in runoff, you can have increases in erosion on stream banks. That can result in the increased transport of sediments. And when you have natural in-stream habitat features such as deep pools or riffles or pebbly areas, they can be filled up with sediments over time. What's also transported are nutrients, heavy metals, and pesticides. And exposure to these substances, either individually or combined altogether, may have acute or chronic effects on aquatic life, going beyond trophic levels, like up with compounding effects. From all of the above factors that I've discussed, benthic macroinvertebrate diversity may decrease, in that pollution intolerant species such as stoneflies, mayflies, and caddisflies will decrease in number, and pollution tolerant species such as chironomids, tubificid worms, amphipods, and snails may remain in the water body or increase in population. With the changes to the temperature regime, members of the fish community, such as trout and sculpin, may decrease. They linked this decreasing population to a threshold of impervious cover increasing above 10%. 10% is usually the cutoff. Next slide. From all of these effects and impacts, it's evident why it's important to conserve vegetation that are adjacent to water bodies. So the primary strategy should be conservation instead of treating a water body after it's been degraded. And when you combine this primary strategy with green infrastructure projects and other best management practices, the negative effects associated with high impervious cover can be lessened in severity, especially the effects that are triggers for forming HABs. And Lauren John will elaborate on this in the next slide.
Okay, thank you, Kelly. So Kelly did a really great job going through the various types of ecosystem services that riparian zones provide. And for this slide, I'm just focusing on two of those ecosystem services, which include nutrient uptake and the shading of surface waters. So according to the EPA, the most effective preventative measures to manage HABs are those that can control the anthropogenic influences that promote blooms. These influences include leaching and runoff of excess nutrients. So riparian zones are actually one of the two biological prevention measures that EPA lists on their website for prevention of cyanobacterial HABs in surface waters. So as you can see on the diagram on this slide, it's a very broad overview of the nitrogen cycle. But I like it because if you just focus on that little red tractor, which in this diagram represents a source of nutrients that we all know are fertilizers. And you can see three arrows coming off of that tractor, which represent the three general pathways that nutrients can take in their life cycle. So the first pathway, which is labeled as runoff, is basically the nutrient just gets taken up with surface water runoff and ends up either being carried into a storm drain or directly into a surface water. The other two pathways involve the nutrient being infiltrated into the soil media, and usually this is done through percolation of surface water into the soil. And from there, once the nutrient is in the soil, it can take one of two paths. It could be leached into the groundwater and end up back potentially into a surface water through that leaching method, or it could be converted into a usable form of nitrates for plant consumption, where it could be absorbed by the roots of plants and stored there. So as Kelly mentioned before, when you have fewer vegetative areas intercepting your stormwater runoff, your nutrients are more likely to take the path of running off directly into surface waters or leaching through the groundwater back into our surface waters, which, as we all know, can contribute to increased nutrient loading and set the stage for eutrophic conditions and potential formation of HABs. The other ecosystem service I wanted to talk about was shading and cooling of watercourses, which helps to reduce higher temperatures and limit the amount of sunlight that reaches the surface water, because we know with elevated levels of nutrients and stagnant water that this is a conducive environment for the rapid multiplication of the bacteria that create HABs. Next slide. So we've talked pretty thoroughly about why riparian zones are important to protect. So for the remainder of this presentation, I'm going to talk a little bit about how we protect riparian zones in New Jersey. And specifically, I'll be focusing on one of our regulatory mechanisms, which is the Flood Hazard Area Control Act rule. So as Kelly showed in an earlier diagram, talking about riparian zones, there are three widths of riparian zones that can be assigned to a regulated water in New Jersey. So we have 300-foot riparian zone, which is our most protective riparian zone, and that is assigned to our Category 1 waterways and all upstream tributaries situated within the same HUC 14 watershed. Below that, we have the 150-foot riparian zone, which, again, I should have caveated this right at the beginning, but these are very site-specific determinations. So although we do have resources and mapping tools that the public can access, such as our surface water quality standards data layer, our HUC 14 watershed layer, and those resources can guide the public when trying to determine the width of a riparian zone. Most of the time, there really needs to be a site-specific review done by the Watershed and Land Management Program staff. But going back to the 150-foot riparian zone, because this is one in particular that really requires our Threatened Endangered Species Unit to be involved in, 150-foot riparian zones are assigned to any trout production water and all upstream waters, including tributaries. They're also assigned to any trout maintenance water and all upstream waters, including tributaries, located within 1 mile of a trout maintenance water. And finally, any segment of water flowing through an area that contains certain threatened or endangered species habitat, or it actually contains a threatened endangered species and or is present or documented habitat for those species, and all upstream waters located within 1 mile of that habitat. And finally, we have our 50-foot riparian zone, which is kind of our default, you can think of, and that is assigned to all regulated waters that don't meet the criteria for a 300-foot or a 150-foot riparian zone. I'd also like to note before moving on that 300-foot riparian zone buffers are also assigned to waterways within certain waterways within the Highlands region. But that authority comes from the Highlands Water Protection and Planning Act rules, not from the flood hazard area rules. Okay, next slide. So there are 6 categories of regulated activities listed here, and these activities could trigger the need for a permit if they are happening within a riparian zone or within a flood hazard area. And a flood hazard area is another type of regulated area under the flood hazard area rules. And this is basically the land area that has been determined to be subject to flooding that may occur as a result of stormwater runoff or tidal flooding. So many of these regulated activities can legally occur within a riparian zone or a flood hazard area if they are proposed and authorized through our permitting process. So I'm going to go over these very quickly. I don't want to read them to you, but generally, number one is any type of grading or excavation activity that could potentially be a regulated activity. Number two is what we're really focusing here on today, which is the clearing, cutting, or removal of riparian zone vegetation. And this includes areas that, such as agricultural areas, that may be periodically cultivated for part of the year. Number three is the creation of impervious surface. Number four is the storage of unsecured materials. And number five is the construction, reconstruction, repair, enlargement, or elevation of a structure. And finally, number six is the conversion of a building into a single-family home, multi-residence building, or a critical building. So numbers 4, 5, and 6 are actually more relevant to flood protection activities that occur within the flood hazard area. 1, 2, and 3 are really what we're focusing on when we're looking at riparian zone disturbances. Next slide. So this will be our last slide, and I'd like to wrap up with the question of, is all riparian zone vegetation quote unquote equal under the flood hazard area rule? And that's kind of a loaded question. The short answer is no, but with the caveat that all riparian zone vegetation has value and is assigned value under the flood hazard area rule. So in any situation where there is a proposal to convert vegetated riparian zone to impervious surface, such as converting farmland into a parking lot or into a warehouse, despite the fact that we consider some sorts of riparian zone actively disturbed, which includes farmland, gardens, maintained lawn, landscaped islands, and parking lot, despite the fact that we acknowledge that certain types of vegetation have been manipulated by anthropogenic means, we still count the conversion of that vegetation and we take that into consideration when we're reviewing permit applications, and we set limits for how much of that vegetation can be disturbed. With that being said, we do have caveats in the rule which encourage the protection of forested lands or undisturbed vegetated areas that have not been yet manipulated by human influence. So in these areas, such as forested areas, herbaceous meadows, any conversion of that vegetation to either a lesser form of that vegetation, as an example, I would say converting a forested area into farmland, that would be considered a permanent impact that has to be accounted for and potentially mitigated for under the rules. So to answer that question, ultimately we do place high value on all vegetation because all vegetation does have that root system that will provide nutrient uptake, but we also acknowledge that certain types of vegetation, such as forested areas, provide additional benefits, such as the shading and cooling, which I talked about earlier, which is particularly relevant to preventing harmful algal blooms. And with that, I think we will wrap it up. Thank you.
Thank you, Kelly. Thank you, Kelly and Lauren. That was great. So moving right along, we now have Dr. Brian LaPonte from Florida Atlantic University. Dr. LaPonte is internationally renowned for his research on water quality and harmful algal blooms in tropical and subtropical seagrass and coral reef ecosystems. He has assessed nutrient pollution and harmful algal blooms in freshwater, estuarine, and coastal systems of South Florida and the Caribbean region. He's also pioneered the use of an ecological nutrient threshold concentrations that initiate harmful algal blooms, as well as the use of stable nitrogen isotopes to fingerprint the source of nitrogen enrichment. And today he's going to be talking about Florida septic studies and HABs. Dr. LaPonte?
Thank you very much. Can you hear me all right?
Yes, we can.
Great. So yeah, I'm going to just briefly go over some of the work I've been involved with here in Florida over my career, which goes back about 4 decades or so. This is a photo of me in Lake Okeechobee on the left, collecting some microcystis, and also in the Caloosahatchee River on the right, in an estuary. So I'll talk a little bit about the emerging problems with microcystis and microcystins and how we're tracking nutrient sources. So in Florida, we have a lot of septic tanks, and that's one of the major, next slide, please. That is one of the major sources of nutrients that we're finding both in the water and in the actual HAB tissue as well. So septic systems are permitted by the Florida Department of Health through Chapter 64E6 of the Florida Administrative Code. And these systems provide primary treatment only. They're really not designed to remove nutrients like ammonium, nitrate, and phosphate, or bacteria, viruses, pharmaceuticals, or organic waste compounds. And we have 12% of our nation's septic systems in the state of Florida. And when you combine that with all the sunshine we have here, warm temperatures, you can grow a lot of algae on the nutrients that are coming out of these septic systems into groundwaters and surface waters. Our geology here is not well suited for septic systems. We have a lot of porous, sandy soils here with high conductivity and very high groundwater tables in our coastal areas where a lot of our population lives. And that'll, allows for rapid movement of the wastewater from the drain field into the groundwater. In fact, many of our studies show that during the seasonally high water levels in the wet season, we have typically less than the required standard of 2 feet separation from the drain field from that seasonally high water table. And in fact, in many cases, the drain fields are sitting right in the groundwater. So obviously these systems cannot function when that happens in the wet season. Next slide. So if we look around the state of Florida, you see Lake Okeechobee down there in central Florida in the south. But all around that, the pink and the red are septic systems. Upwards of 3 million septic systems in Florida. And historically, as we've seen the problem of HABs worsen around the state, initially many pointed to fertilizers as the primary nutrient source supporting these HABs. But as we do more research using, modern techniques like isotope tracing, dual isotope, both oxygen and nitrogen, we're seeing more clearly that wastewater and septic tanks in particular are in many cases accounting for the lion's share. Wakulla Springs, for example, south of our capital of Tallahassee, is an iconic Florida spring, first magnitude spring. And septic systems account for about 51% of the nitrogen load to that system, which now is being impacted by algal blooms. So next slide. My work has focused not just on springs, but more largely estuaries, both the St. Lucie estuary on the east coast of Florida, that's been impacted by a trend of worsening microcystis blooms going back to 2005. And all these blooms we saw beginning then, as well as 2013, 16, and most recently 18, followed extreme rain events, okay? And what happens in South Florida, water from north of Lake Okeechobee, from Orlando down to Lake Okeechobee, that is where 95% of the water and nutrients are coming from into the lake. You often hear they're coming from the farms south of the lake, but that's not true. That water south of the lake generally goes south to the Everglades. So when all this water comes into the lake, we're seeing more and more nitrogen influence coming from north, generating these microcystis blooms that are developing in the lake. And then as the lake exceeds a certain level, the Army Corps releases that water east and west. And the St. Lucie estuary to the east, you know, the salinity goes down, not just from the Lake Okeechobee releases, but also from the basin itself. And that reduced salinity allows this seed microcystis to develop these thick guacamole-like blooms that I'm sure many of you have heard about in recent years during these events. We have advisories for not just for the microcystis blooms, but also fecal bacteria that are also excessive, and not just during these microcystis blooms, but generally during the wet season from the septic systems and other stormwater runoff from impervious surface. We have violations of state fecal standards. The little graph on the bottom right, you can see we've tracked the microcystis from the lake through the C44 canal into the estuary, going from left to right, those bars. And you can see how the stable nitrogen isotope values go up, become more enriched as they see all this wastewater from the, you know, the tens of thousands of septic systems that are affecting this urbanized estuary. Next slide. Yeah, if anyone wants to know more about this particular study, we did publish this paper in 2017 in the journal Harmful Algae about the research in tracing nutrients from septic systems through the groundwater directly right into the algal tissue. Next slide. So we're seeing the same thing happen on the West Coast when that water goes west from Lake Okeechobee during these periods following excessive rain, where the water comes in from the north. Again, you see the stable nitrogen isotopes from Lake Okeechobee going west to Fort Myers and Cape Coral. You can see how those isotope values increase as you really switch from more of a fertilizer signal, which is lower than about +3, where that red line is, into a much stronger wastewater or sewage signal. And on the right, you see the extremely high concentrations of ammonium and phosphate that we see in and around these thick sludge-like blooms of microcystis. 2,000 micromolar ammonium and, gosh, over 150 micromolar soluble reactive phosphorus. For those of you that don't know these units, that's about what you would find in you know, poorly treated secondary sewage, where you're not removing the reactive nutrient species. Those are very high concentrations compared to natural levels. Next slide. So as we heard earlier in Nick's talk, these big events are being driven by these extreme rain events. These are just some of the headlines following Hurricane Irma in 2018. That was actually, the hurricane was in September of 2017, but it spawned algal blooms all around the state. Brown tides in the Indian River Lagoon, red tides on the west coast of Florida, blue-green algae in Lake Okeechobee, and these persisted over the next year or so. So there's kind of a longer-term effect as this runoff moves through the hydraulic system, through our wetlands, into our rivers, streams, estuaries, and coastal waters. And the American Society of Civil Engineers certainly recognizes the need for improved wastewater treatment in Florida, with their recent report card suggesting we need a major multi-billion-dollar upgrade in our wastewater infrastructure. Next slide, please. One of the things we're seeing around Florida, this is just one example, is increasing septic to sewer conversions. This is the Florida Keys that was all on septic tanks. They have all been connected through low pressure sewers or vacuum sewers or gravity sewers to advanced wastewater treatment plants. These have 5-stage Barden Faux biological nitrogen removal that brings that nitrogen from somewhere 70 or 80 milligrams per liter in the wastewater down to around 1 milligram per liter. That technology is really getting awesome. And from there, it goes down a deep well, deeper than around 3,000 feet or so, to get it away from the surface waters that are used for recreation and fisheries. Next slide. Where there is no municipal sewer available, we have new technologies that are emerging called distributed wastewater treatment, DWT. And I just published a study I did on one of these units in Water and Waste Digest. It's the cover story in last month's, the February issue. And it basically is like a little advanced wastewater treatment plant on site in a concrete structure the size of a septic tank. It uses industry standard processes and actually discharges to a drain field or drip irrigation system. And they cost around $14,000 for the unit, and you'd have to an additional expense with a drain field, but they're centrally managed and controlled by the local utility using a cloud-based operating system. Next slide. I got a chance to test this in Polk County, north of Lake Okeechobee, over the past year, and was really quite amazed at the performance of the system. 90 to 95% total nitrogen removal. Not so much for phosphorus, around 40%, but more phosphorus removal can be achieved in the drain field system, particularly if it's tweaked with bold and gold to increase phosphorus absorption through the drain field system. Removed 96% of the total suspended solids and about the same for the carbonaceous biological oxygen demand. So I think this is really going to be a game changer for Florida. Next slide. Number of communities are beginning to use these. They're permitted by Florida DEP currently. And this is just one example in the city of Apopka, where because of the Clean Waterways Act that was passed several years ago and signed by our governor, there's a lot of money coming for wastewater upgrades in Florida, and also federal funding with a recent infrastructure bill being passed. So I think we're going to see, a lot of improvements coming forward. In the case of the city of Apopka, a number of units were installed along the Wekiva River. This is a system that's becoming, more and more eutrophic. Initially, many thought this was due to fertilizers, but as I mentioned previously, with more and more studies, it was clear that septic systems were really a major part of the problem. And next slide. So the bottom line is we are very actively in Florida funding septic to sewer projects to secure Florida's water future. We have just tremendous resources at risk in Florida. Just one of those examples is Silver Springs here, where I got to meet Riku Browning, the gill man and creature from the Black Lagoon. Maybe some of you remember that classic from way back. That's Riku with me at the Florida Spring Fest a couple of years ago. Pretty handsome guy. If you put the next slide up, you'll see what he looked like as the gill man. There he is. So anyway, with that, I'm going to close, and thank you very much for the invitation to present today.
Thank you very much, Doctor. I love the ending. That was great. So our next speaker is the Honorable Michael Francis. Mayor Francis is the mayor of the borough of Hopatcong. He is a member of the New Jersey Highlands Council and vice chairman of Sussex County Planning Board, and also a member of the Land Use Board in the borough of Hopatcong. And the mayor will be talking about making it happen, his town's approach to septic management. Mayor Francis?
Thank you, Carrie. But while I have you, I really want to say that we're going to miss you. You did a tremendous job, even by putting up with me for so many years. But you set the bar pretty high, and today you put together what I would call an all-star cast. I don't know what the hell I'm doing here, but I'll tell you what, you put together a great summit, and so thank you for that.
It wasn't me, it was all the folks who participated, but thank you, Mayor. It's always good to hear from you.
But you're the facilitator, so thanks.
Most
Thank
welcome.
you, Jessica, for helping me with my presentation, because I don't do this real well, and Jessica dolled it up for me a little bit with the background pictures, which, by the way, are Lake Hopatcong. And so we have this area called Crescent Cove. Hudson Avenue is the entire west shore of Crescent Cove. Crescent Cove is about 70 acres. It's kind of a lake within a lake. The mouth of the cove is about 1/10 of a mile, 600-700 feet. So, and the cove for many previous years was called a mud hole for obvious reasons. So it was definitely a challenge. So when we had an opportunity to do the sewers, I try to pay attention to what all these experts say, and they said, we got to sewer the lakefront. And of course, I said, what the hell could be so hard about digging a trench and road and putting pipe in? It can't be that hard, but it is. Hopatcong probably is the opposite of Florida. We're sitting on rock. So as your effluent goes through the sand, ours goes through the top of the rock and goes right into the water. So, it does the same thing. And so that's a little background on Hudson Avenue. And Crescent Cove, by the way, has been vastly improved. And this is going to make it better. The interesting thing about a cove that's protected of that is it responds quickly to different stuff that goes in, including runoff. So when it comes to HAB, if we get some serious runoff, that cove gets pretty bad pretty quick. We put aeration in, which has helped it a lot, but that's for another day. So in my estimation, putting the sewers along that road, or at least most of the road, it's 2,500 foot of sewer line we put in. And by the way, it's up to 38 homes we've taken septic that we've taken off. We extended the line a little bit, got 3 more homes, but thank God for little favors. But next slide. So, when I tell the people I want to spend $500,000 to put some pipe in the ground, they want to know why. I mean, I'm pretty sensitive to spending. I'm a little conservative when it comes to that, actually. So I have to explain and also justify to myself why we're doing it. So we have to do some sanity check while we do this. And of course, septics, as I explained to people, as Brian did, are really have a bad effect on our water, especially when they're close to it. And so removing these nutrients that cause the HABs is very important. Next slide, Jess. So all the homes in that area of town are on septics. And interestingly enough, the Hudson Avenue sits up high and the lakefront properties sit down low, a drop of about anywhere from 10 to 20 feet. So it's almost like a cliff between the road and the homes. And the septics are all lakefront, by the way. And so as you can see, that caused a big problem. And what brought this about is some of the houses had problem with their well. It's all on local wells, and they went to get a new well drilled, and the well driller wouldn't drill it. It was too close to the septic, which all these septics are from the 30s, 40s, and 50s. There's maybe 2 or 3 that are new, so they're pretty bad. We have some that are just 55-gallon drums in the ground, I think. But so that was a real impetus to get us to get this project done. And so go next slide. And so the setbacks on the properties are terrible. I mean, some of the septics are, I don't know how they're working. They're probably not. They're really close to the lake. And again, it's all rock and goes right over the rock. So, and we really, you know, and what we do really is more than the environment. It is. It's about the quality of life. It's about property value. So you can't just say what we're doing is just for one thing. It's for a whole bunch of things, and mostly for the people. We improve our environment. We improve the quality of life for our people. We improve the property value and our economy. I mean, the lake generates a lot of money. We have right in River Stick, right outside the cove, we have a marina, and so when they close the lake because of HABs, he's out of business. So it's a lot of things that take place. And so next slide. And so we actually had to do an environmental impact study when I first proposed was we actually ran this by the Highlands also, because what we don't want to do is become part of the problem. We want to be part of the solution. So our sewer line is under or and in the existing roadway. So that's already been disturbed. And so we minimize the environmental impact of it. Next slide. Now, how we got there. And people say a public buy-in, and you know, some of the stuff that environmental issues actually terrorize people. It intimidates them. They don't know what to do. They hear so many things that could go bad. And so of the 40 people that are 38 people on the road, I actually went to everyone's door and we talked about issues. And of course, it's financial. This is a $500,000 project. And by the way, I can't use taxpayer money for it. It's only the people who are served. And so we talked about all that with the people. And what I did with the people is I said, you know what? I'm going to leave it up to you. I'm not smarter than you. You might be smarter than me. So we're going to take a vote. And if everybody on that road doesn't want to do it, then I go away. You won't hear any more from me, but you take the consequences and you own the consequences, which are, you know, if you want to put a septic system that close to the lake, it costs you probably $50,000 to $150,000 to put one in that's going to comply. So I kind of got their attention with that. Next slide. So that decision was left to the property owners. And again, if the majority agreed, we would move forward. If the majority didn't want them, that was the end of the project. And I put that in writing to them, by the way. Next slide. So the cost of the project was $500,000, give or take. We might come in a little lower, but for all practical purposes, $500,000. And we used the New Jersey Environmental Infrastructure Financing Program, which was called a nano grant, and that's 50% principal forgiveness. So all of a sudden, if you do the math, all of a sudden it became pretty affordable. So our stores cost about $6,000 to hook up, but the assessment fee can only be paid by the people being served. And the way we worked it out, it cost people about $27 a month to cover their assessment fee, which was about $7,000. But the assessment is spread over the length of the loan, which is 20 years. So when people heard that, I got a lot more. And by the way, it wasn't this easy. It took a little while to get here because working with the bureaucracy, it's sometimes not as easy as it sounds. And so next slide. So the sewer line extension is complete as we speak today. And I say the majority of homes are hooked up because we have some real issues with the granite and the rocks and whatnot. And I'm actually going to bring an engineer for me, and we're going to do some vertical drilling at an angle to go down through the bedrock to get to the home, which is probably 30 or 40 feet below the grade of the road. So there's only a few that are not hooked up, but we consider, I think before midsummer, late summer, we should be done. Next slide. And so we really learned a lot from this. What we learned is when you explain to people that they are part of the solution, we found out that there's a little more buy-in. We're not from the government, and we're not here to help. And so when I explained to people the logic that I was using, I got a lot less negativity and a lot more understanding that we would in fact be contributing to the health of our lake, and we take our lake pretty seriously. This HAB stuff is really serious stuff, in my opinion. And, I kind of take it personal when our lake gets closed because it's not healthy to be in it. And so we're looking at other stuff as we go. The sewer line was a major step forward. Crescent Cove has 2 gigantic chambers that have been cleaned out, and they put the biochar in them. That helps. We're currently looking for some help. I have a road that runs drains right directly into the lake. I want to divert that with stormwater management and divert that into a holding pond where we have some plantings. It's a pretty big holding pond, but that should help us a lot. So this is only one step. The aeration was one step. The storm. So what I'm saying is that what we recognize is this is a bunch of incremental steps that we have to do. And so if we pay attention to the increments and we work together on it, I believe that we could make our lake better. So with that, I'm done.
Thank you, Mayor. It's a good story, and good luck as you continue the project in your town.
Well, I'm partnering with the DEP. I could be, all truthfulness, I could be a critic, and I have all these brainy ideas that I bounce off you and Katie, and I'll keep doing that. By the way, I promise not to stop. Good. But it's all for the benefit of our lake.
Yes, it is. Thank you. All right, we were moving on. Our next speaker is Dr. Bridget Noreen Seeger from Nassau. Dr. Seeger is the Nassau lead on the Cyanobacteria Assessment Network project with the goal to validate the cyanobacteria algorithm for U.S. inland waters. And today she's going to be talking about that project and its impact. Dr. Seeger?
Hi, everyone. It's really great to be here today. It's been fun to listen to the solutions and some of the implementation that's already happening in New Jersey. So that's always great to see. So what I'm going to be talking about is the CYAN project, the Cyanobacteria Assessment Network. This is a project that NASA is working on with EPA, NOAA, and USGS. And really what it's about is trying to get data into all of your hands so you can respond to some of the things that we're seeing when it comes to cyanobacteria across the US and in New Jersey, in this case in particular. Next slide. Great, so I don't need to go into why we're worried about cyanobacteria. It's been well covered. We know these tiny little microscopic bacteria are causing some really big issues for everyone, so we can move along to the next slide. All right, and so what we're really concerned about are these cyanobacteria blooms that can be toxic and dangerous. So we can prevent any exposure to these blooms. And kind of the traditional way to do this is to go out with some nets and send out volunteers or people at the water quality districts to take samples. And there are so many lakes across the US and so many things to keep track of. It's limiting to have to go with actual people to lake to lake to lake. So what we've decided to do is try to use the satellites, and the satellites are out in space looking back at the Earth. And so we get near daily coverage of lakes around the world and in the US, and that's where our project is at. So this is a little bit of a summary of what we're providing. A couple of neat things about the data is it actually goes back to 2002. So we have about a 20-year time series. So you can look at what's happening in your lake today, but you can also go back in time and see what was the lake doing, 10 years ago, 20 years ago. Are there other changes that have happened in the area that might be tied to any changes in water quality that you might be seeing? The image that you're seeing is our daily image that we produce. So you see a lot of brown, that's land, but anywhere you see any other coloring, that's an indication of a body of water. So where you see the light gray, that means we have data, but we're not picking up any cyanobacteria. And wherever you see some of the rainbow speckling, that means we're getting cyanobacteria reading in the water. And where you see black, that means there's no data. So we're not doing this for the oceans, or if there's clouds or something like that, you're going to end up with a black pixel. All right, next slide. We'll zoom in a little bit more. So this is just a zoom in on kind of Minnesota, Wisconsin, where there's a lot of lakes. And you can see how handy this product is when we're getting hundreds and hundreds of lakes every day with an indication of what's going on with cyanobacteria. There is some limitation in terms of what lakes we can see. We can't see every lake. The pixel size is 300 meters, so about 1,000 feet. So if you have a lake that's smaller than that, we're not going to be able to resolve it with the satellite data. So next slide. This is what everyone's waiting for. Here's New Jersey. So you can see we have some of that speckling, and you can see some of the different colors. So there's definitely some lakes that are being picked up with some cyanobacteria, but I think I grabbed an image from last summer, and we see a lot of light gray, which means there's not any indication of cyanobacteria in the water, at least from the satellites. So that's pretty good. Next slide. So along with the cyanobacteria index, that kind of satellite product we're producing, we also do daily true color imagery. So this is another thing you can go and get. It's actually very cool to take a look. They're very beautiful images. A couple things to notice is there are a lot of clouds. So if you go one day and there's no data for your region, it could be clouds. And also you can see there's some gaps in the imagery. So the way the satellites go around, there's sometimes missing data. And that gap in the data moves from place to place each day. So sometimes there's just no data for a certain day for an area. So next slide. So here's just the side-by-side of the true color and then also our cyanobacteria index satellite product. So you can see, at least for me, when I'm looking at that true color image, it's hard for me to pull out where there might be a cyanobacteria bloom, where if you look at the image on the right, you can see those rainbow colors, and it's an indication like, oh, there might be something going on in that body of water. So you might want to send someone down to check it out. All right, next slide. So one of the big goals of the Cyan project is actually to get data into the end user's hands. So we have actually a set of apps. So one app is for like a web browser. You can use it on your phones, you can use it on your computers, any sort of interface that you like. And the second one is an actual phone app, but it only works on Android phones. So that's one limitation of that phone app. We're partnering with the EPA. They're actually the ones who support the apps. At NASA, we're providing all the data, and then they're putting it into the apps. So I'm just going to talk through what the apps are like, hopefully get you excited to go get your own app and check out what's going on in your lake. So next slide. So these are just some screenshots from the phone app. You can see across the top, it's a Google Map interface, so it's something very, very familiar. I'm using Lake Okeechobee as an example here, but the apps are really easy. You just kind of zoom in, click on it, and it pops up an image, and it tells you about the last satellite image and how much cyanobacteria it estimated in the water. So if you look at the top middle, you can see it says 13,000. You might not know if that's a lot of cyanobacteria or too little, but the green indicates that it's at a level that might be considered healthy. So the arrows change color. They go green, yellow, orange, red, depending on how much cyanobacteria the satellite is picking up. If you move to the top to the right, you can see I dropped a series of pins of lakes all in a row. So you can imagine if you're driving around with your canoe or you wanted to go for a swim, you can actually see the current conditions in different lakes. And then the final top right image is comparing lakes over time. And I'm going to show a better example of this for New Jersey on the next slide. So we can move on to that. All right, so this is the other way to interact with the data. This is for a web browser, again, for any phone or computer. You can see when you open it, you see this nice map. You can zoom into an area. So you can tell I've been exploring New Jersey recently. So I have pins all over. And again, those pins colors indicate green means low cyanobacteria, yellow, orange, red. So you can change the view. The satellite view is kind of hard to find what you're looking for. So I'm going to zoom in. I'm going to find a lake. So here's Bud Lake and drop a pin. So the satellite data, at least from March 10th, says that the lake's in pretty good condition, very low cyanobacteria. Once you drop a pin, it's actually going to automatically move that lake to your, something called My Locations. So you can see over on the left, there's something My Locations, and then you can find there's Bud Lake since I dropped my pin. And this is going to allow you to explore the actual satellite data, and it's going to allow you to look at the entire time series from that lake. So you can go back in time and see how conditions have changed. So there's that satellite data. You can zoom in, take a look at that lake. So this is from March, so this is right now. You can see there's a lot of gray, which means in this area right now, we're not getting a lot of cyanobacteria, which may not be surprising for spring. But now I'm going to go back. You can see I'm clicking around in the imagery to last September. And now you can see the little pin turned orange. So that means there is higher levels of cyanobacteria. There's the estimated cell counts. you can see how that's changed. And you can click around in the imagery and watch how the blooms change over time. So in this example, I'm using daily imagery, but you can also do weekly if you want to kind of watch conditions change a little bit more quickly. All right, another neat option is you can compare lakes. So these are all lakes in New Jersey. I had them all under the compare tag. And here you have a time series of these different reservoirs, Greenwood Lake and also Bud Lake, from 2019 to 2021. So you can actually see how these different lakes have compared through the different seasons. You can see where summer is, these big increases in blooms. You can see that 2019 and 2021, at least from the satellite, looked like the blooms were a little more intense. Anyways, that was just a quick run through of what that Cyan web app looks like. It's pretty fun. You can go check out your lake. You can show your neighbors how your lake's looking better than their lake or anything like that. So it's just a neat way to play around with the Cyan data and see what's going on. All right, and if you want all the data and you want the whole story, the apps only go back 2 years, so to 2019 right now. But we do have a NASA website where it has all the data all the way back to 2002. You can go, you can find your lake, download all that data. Also, it explains more about the actual product, and there's a bunch of trainings about how to use the apps or how to interact with the data in general. So that's where you're going to get more details on the Cyan project. All right, next slide. That's it. That was a big, quick run through of what we're doing. It was a little window in time, but yeah, reach out anytime, and I'm happy to answer questions.
Very cool. Very cool. I think we're all going to be downloading that app.
It's so much fun.
Very cool.
Yeah.
Thank you, Doctor. All right, so we're approaching our final speaker and then closing remarks. And I'd like to introduce Vic Peretti. He's our section chief in the Bureau of Freshwater and Biological Monitoring, where he manages sampling and analysis of freshwater monitoring throughout the state. And today he's going to be talking about the new autonomous surface vehicle for water monitoring in New Jersey lakes. Vic? Vic, we're not able to hear you. We still can't hear you. You may want to exit and then try to come back in. Sometimes that works. Or if you have a headset, that might be part of the problem. Still can't hear you. Hey, Jess, any guidance here?
I don't know if I'm the one to go to. The 3 dots, Vic, for device settings. What do you have your speaker and stuff on? Or microphone on? Still can't hear you. Nope. Nope. Do you want to try? We talk now? No. Oh, somebody else.
Still not able to hear you.
Okay. We'll give him a second.
Can you hear me now?
Yes, we can.
Okay.
Yay.
There you go.
All right. I don't know what that was. I just left and came back. So
Sometimes that's all you need to do.
okay. Sorry about that. Yeah. So today again, I just wanted to thank Carrie for facilitating this, and your stellar career, so I congratulate you on that.
Thank you.
And so today I'll be talking about a new piece of technology we've acquired, or we're actually getting it on Friday. And you've heard throughout the presentations, our theme has been prevention and management of lakes, but the underlying need for everything is good data. You need good data to know how to respond and manage effectively. So I'm going to be talking about this new tool we purchased. Next slide, please. So just a little background. We've been using, and whenever we're able to, advanced technology to monitor and screen for HABs, as well as water quality to determine factors that may contribute to or predict HAB activity. And among this new technology are continuous monitoring telemetry buoys. In 2021, we deployed 9 buoys with real-time data in lakes that had recreational and/or drinking water significance, and also had repeated HAB occurrence and duration. And all of the continuous data is collected at strategic sites that we, that has had HAB activity in the past. It may not only reflect the static point and depth where the buoy is located. So we sought out a way to characterize conditions over the entire water body. Next slide, please. And what our research landed on was an autonomous surface vehicle, or an ASV. And this is a robotic vessel that can monitor status, position, and aspects of its operational environment to automatically navigate and acquire data without the need for continual operator oversight. In an effort to enhance the ability to profile the entire water body, we purchased an ASV using funds awarded through the U.S. EPA Monitoring Initiative strategy. And these funds are awarded for expanded or enhanced monitoring activities that build upon the state's monitoring program. Next slide. So the ASV we purchased is the YSI HiCat, and this employs the same multi-parameter meter and probe technology as the continuous monitoring buoys. So that's why I mentioned them in the beginning. So these probes and meters are interchangeable with what we already have. So it's going to be a cost savings, as far as being able to interchange probes when we need to, and also the software and data outputs are the same. So it's, we get a head start on being able to use this. The ASV is portable. It's designed specifically to give surveyors access to data in remote areas that have previously been difficult or expensive or even impossible to acquire. The sensors collect a wide range of water quality and hydrographic data. They collect it in a pre-programmed lawnmower pattern that automatically goes back and forth in the water. And it goes over the entire lake. We can program it to do the whole area of the lake. It can then visually extrapolate a continuum of conditions on the surface, and I'll show you some examples in a little bit. The sensors can simultaneously run, or you could be quickly added at any time. So you could do just temperature, you could do pH and temperature, you could add them as you need them, or do them all at the same time. So this results in more efficient surveys and rapid data acquisition. Next slide. So the intent is to use the HiCat at water bodies to map HAB occurrence, water quality studies, source water volumetric calculations, habitat mapping, and general bathymetry. It's anticipated to begin this year. Like I said, we're supposed to get the actual unit on Friday, and we're going to deploy these at a subset of lakes where we already have buoys. We intend to perform lake surveys using this device several times during the year to capture different water quality and HAB conditions over the course of the growing season. Next slide. So before we purchased it, we had a demonstration at a small portion of Assunpink Lake. That small portion is circled in green right here. And I'll show you what kind of capabilities it has. So next slide. So this is a couple of examples of the visual outputs it's capable of. So the left is a depth profile at 0.5 meter increments. So this particular small portion of the lake is about 4 meters at its deepest, and you'll see that's colored in purple, that 4 meter mark. The right is chlorophyll A. So Assunpink Lake's a pretty clean lake. And you can see that the chlorophyll levels are pretty uniform at this part of the lake, only in about the 2 microgram per liter range, which is pretty low. You've heard many speakers talk about eutrophic lakes. So usually that means a chlorophyll level of about 4 or above is considered eutrophic. Our particular unit will have a phycocyanin probe to measure the cyanobacteria pigment. For this demonstration, they brought out a chlorophyll A probe. So this will be able to map out the distribution of the phycocyanin levels throughout a lake, so we could determine if there's any hotspots, so to speak, any areas where the HAB may be emanating from, things like that. So it's going to be a real, just rather having the points on a lake for data, this is going to map out the entire lake. Next slide. These are a couple more examples. Temperature on the left. And again, another important parameter. You saw Scott's presentation. He had a pretty dramatic demonstration of how high temperatures could get in stormwater outfalls and runoff. This is going to be a tool where we could possibly find sources of runoff that's entering a lake that could be contributing to HAB production. On the right is another example. It's dissolved oxygen percent saturation. Again, Fred mentioned the importance of dissolved oxygen, especially anoxic conditions that can contribute to increased nutrients in the lake. So a lot of important parameters that we'll be able to map out, not just at a discrete site, but over the entire lake. And last slide, please. So we hope for next summit we could have a wealth of data to present, maybe some really cool maps. So we're real excited about this. My contact information, and feel free to contact me if you have any questions. Thanks.
Vic, that looks like a pretty cool little vessel. We look forward to seeing it in New Jersey lakes. Okay, before I introduce our final speaker, who will be giving closing remarks, I would just like to say thank you to all of you, to especially my DEP family, for sharing 34 years with me and giving me the honor and privilege of serving the residents of New Jersey. I will miss working with you and hope that my path does cross yours at some point in the future. And now I'm going to turn it over to my Assistant Commissioner of Water Resource Management, Patricia Gardner, who will give us some closing remarks and thoughts on today's discussions. Pat?
Thank you very much, Carrie. I guess it's not often that I get to be at a meeting and also see the creature from the Black Lagoon and a NASA scientist. This is the first for me, so I really appreciated that. I'm going to give an overview of where the DEP is, kind of an annual report for the group. Next slide. Prior to the 2021 season, the cyanotoxin recreational advisory values were updated using revised exposure assumption to provide better protection for children based on the most recent science. Saxitoxin was also added as a fourth toxin, as this has been a toxin of concern in other areas of the country. This guidance is reviewed annually to ensure the protection of public health, and upon our annual review, there has been no recent scientific information that would change these thresholds, and the strategy will remain the same for 2022. In an effort to enhance HAB recreational risk communication, the department has reviewed the guidance for recreational activities displayed on the alert posting signs. And it was determined that kayaking in New Jersey is more aligned with secondary contact recreation like canoeing and not primary recreation. It was recommended to revise the orange advisory posting sign to reflect actual New Jersey recreational activities, and the red advised against on the kayak icon has been changed to yellow, use caution. Kayakers should still use caution at water bodies where a HAB is confirmed at an advisory alert tier level. And this change will only affect the advisory sign, and all other signs will remain the same. And the new advisory alert sign is available for download and posting on the HAB website. Next slide. The DEP will continue to summarize HAB conditions from the previous season with a comparison to past years in an annual HAB summary report. In 2021, DEP responded to reports of suspected HABs at 55 water bodies. Of these, 35 water bodies had at least one site confirmed by laboratory analysis at having a HAB at or above a watch alert level. These 55 reports of suspected HABs represent a 44% decrease from 2020. This translated into a significant decrease of water bodies with confirmed HABs by 24%. Although a decrease was observed in 2021, compared to 2020, the total confirmed HABs in 2021 exceeded the yearly totals for 2017 through 2019. And this report is expected to be posted in April. Next slide. The AmeriCorps New Jersey Watershed Ambassadors Program is administered by the New Jersey Department of Environmental Protection's Division of Water Monitoring Standards and Pesticide Control. The goals of the program are to provide watershed stewardship through education and direct community involvement, and to monitor stream health through performing visual and biological assessments. Individual AmeriCorps members are assigned to each of New Jersey's 20 watershed management areas to serve as watershed ambassadors to their watershed communities. To learn more about this program and how it can assist your community, contact the program manager, Amanda Baxa, and her email address is on the slide. Next slide. Since the fall of 2021, the department has been hard at work assessing and evaluating how the department manages watersheds within its program areas. While we are already managing watersheds, we wanted to ensure that our programs are working efficiently and collectively to continue to improve water quality. We are building upon our existing practices through the identification of data gaps, communication gaps, or through the identification of new efforts that department can take when it comes to watershed. And the department intends to roll this new internal approach to watershed management out this summer. We are also working to build a more complete inventory of stormwater management assets by building out the existing databases and tapping into existing resources to manage this useful data. This data will be shared with the public to foster better asset management, resilience, and emergency management planning, local planning, surface water track down, and as a springboard for watershed utilities. I also want to thank the presenters, the HAB Summit planning group, and all the attendees for taking time out of your busy schedules to attend. And collectively, we are making a difference. Thank you.
Thank you, everyone.